The Enigma app allows you to build a library of Turing machines and then play them in a song format. And its little brother, Enigma Jr, is an applet, so it can run in both halves of Hemispheres, like you see I have starting here. Enigma Jr takes Turing machines out of that library and then allows you to play them, but more importantly, you can select between which ones to play by using control voltage. What do I mean by a library of Turing machines? I mean, what are we actually talking about here? So in all of the other examples, say for example, we look at say shift gate here or shift register, you get one copy to play with. So whatever you have here is whatever you get to play. Similarly with shift register, there's a shift register. It is what it is. You program it. You could save its state, but once you've changed the parameters on it and you haven't saved it, you've lost what was there previously. What if there was a way, though, that you could save all of these settings in some addressable format? And that's the idea behind Enigma. It allows you to build a library of Turing machines with all of their corresponding settings that sound pretty good, that you might want to use again in the future. You liked the little melody that came out of it, so you said, oh, I'm going to save that. We'll do a quick tour through the Enigma Jr app so you can understand what's going on. As always, this is an applet, so it can run in left or right hemisphere. I have it running in both of the hemispheres today. The parameters, you navigate through them by pressing the corresponding knob. So I'm going to look at the left Enigma Jr here, but the same principles obviously apply to the right one. The first parameter that you choose is selecting the Turing machine you're going to play. There are 40 of them in banks A through E, and there are 8 Turing machines per bank. As before, there's the probability that the Turing machine will generate new notes in it using the p-value here. You change that. And now we come to the two parameter definitions, the output parameter definitions, the A and B here, like you see on the screen. This allows you to specify what output A does and output B, or of course output C and D if you're in the right hemisphere. Output A is node 4 and output B is trigger. What trigger means is whenever there's a 1 value at bit 0 of the shift register, a new trigger gets generated. But what does node 4 mean? That talks about how many bits of information are used to create the value that will be output. The values that are available to you here for this parameter are 3, 4, 5, 6, 7, and you have mod and expression. And of course, it can also be a gate or a trigger. Let's look at what they mean. Node 3 means use 3 bits of the value of the register to create a value. 3 bits corresponds to a range of 0 to 7. So that means the notes that will be generated are just 8 notes of the selected scale. If I set this to node 4, I'll quantize it to 4 bits of information, so 16 notes. The other values it can take on are mod, expression, and then trigger and gate. Mod and expression, if we're just outputting CV, mean the same thing. It takes the lowest 8 bits of the register and uses that to generate a 0 to 5 volt scaled value. And then trigger and gate, you can set A and B to be both trigger and gate. Trigger generates a trigger, as I said, whenever there is a 1 bit in the lowest bit, bit 0. Gate outputs a high when bit 0 is 1, and it stays high until bit 0 goes to 0. We're going to use the outputs of the Enigma Jr applets as modulation sources and a trigger into BIA. So I'm just going to patch the trigger output here, B, into the trigger input of the BIA. Let's take a listen. Okay, so very machine gun style drumming going on there. And you see every time the clock generates a new value, it's generating a trigger. Let's go ahead and modulate that. We will throw a different color patch cable. Let's use orange for the pitch. So I'm going to use output A of the first Enigma Jr into the pitch. Just a little bit of variation there by varying the pitch. Of course, we don't have to stop there. We can use the output of the second Enigma Jr applet here. I'll patch output C, for example, into fold. And now we're getting even more craziness going on. And say we could use this green patch cable here, and we could patch, I just for fun put a gate on output D, decay. Now at this stage, it's like getting into real industrial music territory, but you kind of hear that all of those changes are being done very rhythmically. Now let's add in a little bit of a kind of a top line melody over it using the twin waves. So we'll just patch the audio output of the twin waves here. Let's patch this gate output here from Penrose. That goes high every time it quantizes a new value. I'm going to maybe patch the input to Penrose from this ABC here. And I'm going to throw an LFO into the quantizer as well from Pam's new workout. And then what I want to do is take the output of the quantizer into the volts per octave input here, so we can play a melody. And then we just need a trigger. So output 7 here, I think I've set this up as a trigger. Every time the trigger goes into the quantizer, it'll quantize it to the selected scale. And it's hard to see. You may be able to see it there on the camera, but there are little lights on around these buttons. And as you tap them, you can dial in and out notes. It's very immediate. That's why I chose this over quantizing on Palms, because you can just go dum 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 and you can choose a new quantization and totally change what's coming out. Well, that was a whole heap of fun. But we're missing out on one of the best parts of Enigma Jr, which is choosing or selecting different Turing machines to play. So if I just turn off the quantizer here so that the twin waves will no longer generate any sound, by changing the Turing machine that's playing, I'm changing the rhythmic structure. And after all, if I can change it manually, I can change it via CV. And if I can do that, I can create even more randomness in the sound that I'm generating. The CV2 input of the hemisphere half, whether it's this side or this side, allows you to select the Turing machine to play. I've patched a random value generator here from Palms into CV2 input on the left-hand side Enigma Jr. So watch as the Turing machine changes now as this plays. So we're on B4, D2, C3. So obviously that's going to completely change the rhythmic structure of the sound coming out of BIA. Let's use the Enigma Jr Turing machine on the right-hand side now to actually play a melody rather than just modulating the values in the BIA. So just like in previous examples, I've patched this up so that the pitch output comes out of output A, and I'm generating a gate out of output B. Normally you'd probably put an envelope in there, to trigger with the trigger output, but we'll just use the gate for now. We're going to send a random CV value from output 3 here on Palms into the CV2 input here on Enigma Jr on the right-hand side hemisphere. We have a very interesting rhythmic modulation going on of BIA coming from one Turing machine here on the left Enigma Jr, and then the right Enigma Jr is being used to generate pitch information, which we're playing over here on twin waves. Finally, we get to the Enigma app itself. Enigma has the concept of a register library, and so we will use that to structure songs, just like you would lay out samples in a DAW, or maybe you'd lay out notes on a grid for a drum sequencer or a synthesizer sequencer. Here we are laying out Turing machines on a set of 4 tracks. Enigma consists of 4 screens which allow you to manage the library of registers and then create songs with them. We start out on the library screen. So we start here, you see library. And as the name would suggest, this lets you manage a library of 40 different shift registers from A1 all the way up through E8, and it loops around when you turn past the end. Turing machines are stored in the library, they're frozen. Now, you've seen previously how when you're clocking it, the Turing machine is ticking away, generating new values. But when you store them in the register library, they're stored in a frozen state, ready for you to take them and use them somewhere else, just like we did with Enigma Jr. To adjust the contents of the register, you use the write encoder here, so we could adjust, for example, the length, in other words, the number of steps that are in the register, the probability that there will be a change. And when you click down here again, you can actually rotate the register. Look, I can see how this here is rotating as I turn the right knob. Once we've defined our registers, or we're happy with the default set that starts up, Press the left knob again and we come to the assign screen. Now you notice the text change very quickly here on the right hand side. What's going on? Well, there's a little bit of help text shown to show you what the up and down buttons will do in a particular screen. So here, up is add step and down is delete step. The assign screen allows us to assign the outputs, the 4 outputs A, B, C, and D. Remember, this is an app, so it's running in the complete Ornament and Crime. The outputs themselves, A through D, and they're mapped onto certain tracks. Now, what are these tracks? You think of a classic sequencer having multiple tracks, like a Digitact or Digiton has 4 tracks, for example. Likewise, you can have up to 4 tracks of Turing machines all playing in parallel. You don't have to use all 4 tracks. You can use 1 track, you can use 2 tracks, 3 tracks, whatever works for you. In this setup, output A and B are mapped onto track 1. And output, I turn the left knob to move between them. Output C and D are for track 2. Let's go look on the right hand side of the screen to understand what's going on. So I have mapped it onto track 1. I'm turning the right encoder here to change the track. Press the right encoder to move to the next field. The output range now is going to be 3 bits, which is 8 notes. Press it again, the quantization, and we could set the output of a MIDI channel tied to that track. So much like a standard sequencer, if you're playing a Turing machine or a register, generates a note, you can send that out a MIDI channel, just like a classic sequencer. You would use the USB port on the back of the Ornament and Crime to hook that into your DAW or into a MIDI hub or something like that to forward out to other synths. Let's take another look. Here's output B. Now, again, it's on track 1, but it's set to be a trigger. Remember, like previously, we had triggers and gates on our Enigma Jr. So this shows that outputs A and B are generating notes and triggers. Let's take a look at output C. Output C is mapped onto track 2, and track 2 is going to be playing the BIA. So straight away, it's just like a regular synth. Track 1 is the pitch and trigger for the Basimilus Iteratis, and track 2 are the pitches and some modulation values for the BIA. So this is going to be a trigger, and output D is set to track 2 modulation. So we're going to generate an 8-bit modulation value from 0 to 5 volts from track 2 on output D. Press the button again, and now we get into song mode. This is where we build our songs. You have your 4 tracks, 1, 2, 3, and 4. Over here on the right-hand side, this lets us define the steps in the track. So just like a classic step sequencer, you go in and say, step 1 is this, step 2 is that. I've created a 3-step progression here, 1, 2, and 3 on track 1. I'll just press the right encoder. It says take register A1, and it has a probability of changing the bits 9%, so it'll randomize itself a little bit less than 1 in 10 iterations. Loop that 3 times and don't transpose it. So +0 is the transpose. You see I can move it up or down. Go back over to here, see where it's flashing on the number. Now let's look at step 2. Take register A5, loop it twice, don't transpose it. Step 3, take register B6, loop it 3 times, but transpose it up 3 semitones. And then we get to the end of step 4 here. Likewise, track 2 is composed of a very simple setup, which is just 1 step that says play, register A3, loop it twice, and then just go back around. We've set up the assignments of the outputs, so we're going to connect those up. So let's do that really quickly. Another press on the left button brings me finally to the play window. The play window is where you watch your tracks playing. Let's take a look at some of the things you see here. We have our 4 tracks, what currently is the step they're playing and what loop on that step they're playing. You're going to see the clock divider here, and the little indicator here is either a loop or a arrow. Arrow means 1 shot, so it'll play the track through to the end and finish. Up top here, you see the play pause indicator. You can hit the up arrow to play and pause independently. Now I have it set to play. Obviously, nothing is going to happen because I haven't set a clock yet. Let's do that. Now we finally hear something happening. Let's take a look at the screen. We're on step 2 here on track 1, playing register A5. And we're on step 1, because there is only 1 step on track 2. We're looping it twice. So the first number is the step number, and the second number is how many times of that step is looping. And then you have the register, and then we have the play symbols. All of this can be CV controlled. Digital 2 is the reset input. So there, I sent a little gate in And now I've reset the input here. Watch again. I'm going to play. It's playing away. Tap a gate in. And now I go back around and reset the song to the beginning. I can also send in a play pause signal. So on digital 4, we'll use this gate generator here. But if you need manual gates, by the way, this module from Modulaire Maritime is fantastic. It's the Deca, generates 4 instantaneous touch gates. You can have gated voltage source here, which is very handy for testing things. And you use these gates to mute or play audio or CV. Very handy little tool to have in any setup. Watch here when I send a gate in, the play pause indicator changes from play to pause, play to pause. So if we were playing away, now it's playing, I will send that gate in and pause the playback. See, the play icons are flashing just like CD players in the olden days. The clock is still coming in here from Palms, but it's paused because I gated it. Now we do it again and we're back to playing. And that's the basic principle of Enigma. You set up a library of registers, you assign a set of outputs, you build a song by laying the registers out in the order you want them to be played in, and then you go to your play window and you send it a clock, and it plays the registers for you.